All right, in this video, we are going to look at test 4. All right, calculate the pH of a buffer that is 0.225 molar acid and 0.162 molar base. You might be asking yourself, how do I know which one's the acid and which one's the base? Look at what's in front. One has an H, one has a metal. Bases always go with the metal. So this is a buffer. How do I know that? The only difference between these, other than the metal, you can ignore the metal, is that there's a hydrogen difference. So pH equals pKa plus log of base divided by acid. That was so nice. I even gave you the pKa instead of just the Ka plus log of 0.162 divided by 0.225. All right, I don't even need to do a calculation for this. Why? Because this is a buffer. Remember, a buffer has a pH, a range that is good from +1 or -1, your pKa. So I would expect my answer to between 3.74 and 5.74. I have more acid than base, right? So as an acid, if you have more acid than base, basically your pH drops. So that's 4.60. That's the only answer that fulfills my criteria. You could calculate it too. You should get 4.60. All right, which of the following is true? The equivalency point is where the volume of acid equals volume base. Nope, well, the volumes don't have to be the same. The equivalency point to pH is always 7. No, it can be different. A titration curve is a plot of pH versus the base to acid ratio. It sure isn't, because you don't know, sometimes you don't know the concentration of the acid. So D, none of the above is true. 3, when titrating an HCl solution with KOH at 25. Okay, we have two strong, excuse me. We got two strong acids here. So when two strong acids interact, if you don't know what's going to happen, you write down the chemical equation. Yeah, very good. I know you said it with me out there in GB land. You make H2O plus KCl, neutral, neutral. So at the equivalency point, when they are neutralized, pH is 7. Molar solubility time. Remember, molar solubility means my lead sulfate is breaking down to lead and sulfate. KSP is the concentration of lead times sulfate. I want to know what molar solubility is. Basically, I want to know these concentrations. So since these are 1-to-1, these are x squared. That is equal to 1.82 times 10 to the minus 8. I'm guessing that's 1.35 times 10 to the minus 4, but let's double check this one. (1.35 times 10 to the minus 4. Let me check. Yep, times 10 to the minus 4. So it is B. B is your answer there. All right, 5. Determine molar solubility of AgBr in a solution that is 0.120 molar sodium bromide. So this is the common ion effect. That sodium bromide is going to break down to sodium plus bromide. So your starting concentration of bromide is 1.20. Here we have a molar solubility in KSP. So AgBr is going to break down to Ag plus Br minus. This is a solid. KSP equals the concentration of Ag multiplied by Br. The only difference here is that we know we have a starting concentration Br. It's 1.20. So Ag is still X, because I don't know that concentration. I know Br, it's 0.120. And KSP is 7.7 times 10 to the minus 13. So I'm going to divide that. Guessing that's the minus 12 value, but we will check. We will do our due diligence. 6.41 times 10 to the minus 12. So that is D. All right. 6, a spontaneous reaction occurs without outgoing outside intervention. D. The second law of thermodynamics states that a spontaneous reaction, the entropy of the universe increases. C. Which of these processes entropy decreases? A gas goes to a liquid. A liquid is more ordered. So that's B. Exothermic. So that's negative delta H. And if I release heat into the system, or sorry, heat into the surroundings, the entropy of the surroundings increase. So that's A. Consider a reaction with negative delta H and negative delta G. Delta G equals delta H minus T delta S. Negative. This is negative. That makes this as a positive with temperature. All right. So be spontaneous. I want G to be negative. That means I don't want my temperature to be high. So this will only be spontaneous at low temperatures. All right, 11. What is the order of entropy? So solid has the least, followed by liquid, followed by gas. That's E. 12. What's delta S? So products minus reactants, 219.3 minus 200.9 plus 130.7. So this is negative, 331 basically. So 219 minus 331, and that's roughly 1112. So there's your answer there. C. 13. What is delta G if given this stuff? So delta G equals delta G naught plus RT ln of Q. All right, Q is O3 squared divided by O2 to the power of 3. There's my concentration. So delta G equals 326 plus 8.314 times 10 to the minus 3, right? Because we want everything to be in kilojoules, times our temperature, 298, times a natural log of 5.2 squared divided by 0.41 cubed. Believe when you do that math, that answer is 8. All right. But actually, let me check that before I move on. I'm just going off memory for that one, but it doesn't hurt, right? So 5.2 squared, and I'm going to divide that by 0.41 raised to the power of 3. Take the natural log of that times 298 times 8.314 times 10 to the minus 3. Yep, 341. All right. What is true if the natural log of k is 1 and natural log of k of 1 is 0? So delta G is 0 at that condition. In a galvanic cell, the cathode is where oxidation happens. No, red cat. So reduction. So that's B. Anox, red cat. 16, what's a salt bridge? So a salt bridge is a pathway by which counter ions can flow between the half cells without the solutions totally mixing. D. 17, all right. So tin is 0 to plus 2. So that means I lost electrons. So that's my anode. Silver plus to 0, that's my cathode. E cell equals cat minus anode. So my cathode is 80 minus a negative 0.14. So that's positive 0.94. Which of the following? Oh, so these are from test 3. So those of you in Monday, Wednesday, Friday, if you're watching this, go to test 3 for these answers. Those of you who are on Tuesday, Thursday, you won't have these questions. All right, let's do our short answers here. HF and KOH. So what's the chemical reaction? So an acid and a base reaction. makes F minus plus H2O. What's the equivalency point? M1V1 equals M2V2. I made the interesting choice of having these be the same molarity, so the volume is actually the same as 250 milliliter. At the equivalency point, look what you have. You have water, which is neutral, F minus, which is a base. A base makes a solution above a pH of 7. So above pH of 7 there. All right. This problem was on the homework. I more or less took it straight from there. But yeah, I'm mixing HCl with NaOH. What's my pH? So first thing you do is you want to convert to moles. So I'm going to take my molarity of HCl, multiplied by my volume in liters to get 0.004 moles of HCl. Do the same thing with my base. 0.125 times 0.01 liters is 0.00125. That's supposed to be a 5. NaOH. This is a limiting reactant problem since they react completely. So I'm going to subtract 0.00125 from each. So that should be 0.00275 moles of acid left over, right? Because these are reacting. Let's just write that chemical reaction. And AOH makes water plus sodium chloride. All right, I want pH, so HCl breaks down completely. So I have my moles and I need my concentration to, or my volume to be a molarity. So I just mix two volumes together. So my volume is 0.30 liters. So my concentration of HCl then is 0.00275 divided by, I'm not typing, 0.00275 divided by 0.3. Do minus log of that. pH is 1.04. So my pH is 1.04. My hydronium was 0.0917. Right. And that's all the questions you're going to get, because the other ones I am hiding. I might repeat those. But yeah, if you have any questions, let me know as always. Otherwise, study hard. See you in a little bit.